Electric field due to point charges. A point charge is placed at each corner of a square with side length A. So this is a square with side length A. We have charges plus Q, minus Q, minus Q at the corners. All charges have magnitude Q. Two of the charges are positive and two are negative. What is the direction of the net electric field at the center of the square due to the four charges, and what is its magnitude in terms of Q and A? Okay, so you can see that we have charge 1, charge 2, charge 3, and charge 4. Due to charge 1, we're going to have an electric field pointing in this direction, and due to charge 2 it will be pointing in this direction. So this is mislabeled. This is due to charge 2. This is due to charge 1. And we will have an electric field pointing towards charge 3 and pointing towards charge 4. Now, what is important is the distance between the point charge and the point of interest where we would like to find the electric field. So that distance I call x. You can see that we have an isosceles triangle here. This is a over 2, a over 2, and this part is also a over 2. So these two are the same, a over 2. So we can calculate the distance between the point of interest and the point charge that creates the electric field at that point. And we can set up our coordinate system here. So first thing I want to do is note that we have x squared is equal to, that's the hypotenuse of this right triangle. So it's going to be equal to a squared over 4 plus a squared over 4. So that we find the distance between the point charges and the center point to be a square root 2 divided by 2. And what is the electric field due to a point charge? So let's recall that the electric field due to point charge is Coulomb's constant, 1 over 4 pi epsilon 0. The charge Q divided by r squared in r hat direction. So if this is for a positive charge, you can see that r hat direction is radially outward from the charge. So at this point, the electric field would be pointing radially outwards due to this positive charge. And that's exactly what we have done here. Due to the first charge, it's radially outwards, so that's E plus 1. This is going to be E plus 2. This is E minus 3 because it's negative. Now it's pointing towards the charge. And for the fourth charge, it's pointing towards the fourth charge. Okay, now we can calculate the electric field. So the electric field at this point will be due to all of these four charges, and because the amount of charge and the distance to the point is the same, identical for all of them, the magnitude of the electric field will be identical. So for the first charge we have E plus 1. The magnitude is the same as the magnitude of the electric field for E plus 2. It's the same as the magnitude of the electric field for E minus 1. So I call this E minus 3. And the other one is E minus. That's the fourth charge. So this is going to give me Coulomb's constant, 1 over 4 pi epsilon 0. The charge is Q. The distance is a square root 2 over 2. So we're going to take the square of a square root 2 divided by 2 square. So this is going to give us Q divided by 2 pi epsilon 0 a squared. Now you can see that we have 2a squared over 4, so 4's will cancel. We'll get 2 pi epsilon 0 a squared. All right, now what is the electric field due to the first positive charge, E plus 1? So E plus 1, you can see here, is pointing in this direction. So we're going to consider cosine 45 in minus I hat direction. So minus E cosine 45 I hat. And then we will have the y component. So we will consider, because this angle is 45 degrees, we will consider the y component. Now that will be in minus j hat direction. So minus E sine 45 j hat direction. Now, as for the second charge, E plus 2, we will have the electric field E. So that creates this electric field, cosine 45 in plus I hat, sine 45 in minus j hat direction. So E cosine 45 I hat minus E sine 45 j hat. And for the third charge, E minus 3, we will have minus E cosine 45 I hat minus E sine 45 j hat. So that is this red electric field, E minus 3. So cosine 45 minus I hat, sine 45 minus j hat. And for the fourth charge, E minus 4, that is this charge here, we will have cosine 45 I hat, sine 45 minus j hat. So it's going to be E cosine 45 I hat minus E sine 45 j hat. So we will add all of these electric fields to get the final answer. So we obtain the total electric field at this point to be, you can see that these are canceling in pairs. So this is canceling this one. And you can see this is canceling this one when I add it up. So I'm left with only the y-axis components. So that gives me minus 4e sine 45 j hat. So this gives me E total is equal to, so for E I substitute Q divided by 2 pi epsilon 0 a squared. So this is going to be minus 4Q divided by 2 pi epsilon 0 a squared. Now sine 45 is square root 2 over 2 in j hat direction. And therefore we find that the total electric field is going to be, so you have 2, 2, 4, and 4's will cancel here. So this will get rid of this one and this one. And I will be left with minus square root 2Q divided by pi epsilon 0 a square j hat, or I can write it in terms of Coulomb's constant K, if I multiply top and bottom with 4, it is minus 4 square root 2 KQ over A square J hat. All right. And what is the direction? The direction of the electric field. The direction is downward. So that's going to be the direction of the electric field at the center point. All right, so in this problem, we looked at the electric field due to 4 charges at the corners of a cube at the center of the cube. And 2 of the charges are positive, 2 of the charges are negative, arranged in this manner. We're using the formula for electric field due to a point charge, 1 over 4 pi epsilon 0, or K, Q over R square in R hat direction, where R hat is radially outward for positive charge here. So it's going to be in minus R hat direction if it is a negative charge. So it will be, electric field will be pointing towards the negative charge at this point. So the first task is to find the distance between the point charges and the point of interest, and that distance is x, and that can be calculated using Pythagorean theorem for the right triangle here. We find x to be a square root 2 over 2. And then we calculate the electric field due to charge 1, charge 2, charge 3, and charge 4 separately. For 1 and 2, these are radially outward, so they're going to be pointing out in this direction. For charge 3 and 4, pointing towards the charges. And we can see that even from this figure, the x components will cancel, the y components will add up, giving us a total electric field in minus j hat direction. We note that because the amount of charge and the distance is the same, the magnitude of the electric field is identical. It is 1 over 4 pi epsilon 0 q over a squared 2 over 2 squared. So 2 squared, 4's cancel. We have 2 pi epsilon 0 a squared at the bottom. So when we write the electric field components, the x components are cosine 45 I hat for e plus 2 and e minus 4, and minus cosine 45 I hat for e plus 1 and e minus 3. And for the y components, they're all sine 45 minus j hat direction. So these x components cancel, and e times sine 45 j hat multiplied by 4 and in minus j hat direction gives us minus 4 e sine 45 j hat, and we substitute for e our result here, and we obtain our final answer minus square root 2 q over pi epsilon 0 a squared j hat, and the direction is downward as expected.